after all the 4 presentations, I will open the floor for questions and anyone can ask. And we also received some questions ahead of time, which we can use to stimulate the conversation. Please note that this presentation is being recorded and will be available on ESCAP's website within a week with the presentation slides as well. So without any further ado, let's start with the first presentation by Mr. Michael Choi. He's a statistician at the Census and Statistics Department in Hong Kong, China. So Michael, you have the floor.
Let me share the screen first. Can you all hear my voice?
Yes, I can hear you.
Okay. Presentation mode. Oh, please wait. Display settings swap. Okay, so good morning, good afternoon, or good evening, everyone. I'm Michael Choi from Census and Statistics Department in Hong Kong, China. And thank you for this occasion for me to present our work on the coding classification with AI. And actually, it is the application on the auto coding for our population census. So today we are going to talk about the background, our application, and also our development about our auto coding. So here is some background first. Our process on coding and editing in previous census and our general household surveys are involved with the manual coding in the industry and occupation code, and it might involve many work in the coding process. And we will try to transform those free text description on the open-ended questions into the code for us to do the data dissemination. And this is the background why we do before, and we try to do it in a more automatically way, on a more automatical way with the AI application. So our work is we try to develop an AI classification model for both occupation and industry code with the risk-based mechanism with the human in the loop. And after developing those models, we do the proof of concept and do the data analysis through those survey rounds or during the pilot runs of the our population census. And finally, we developed our system, our framework integrated with our data collection platform, and which is extendable for other codes or other survey, and is flexible for us to use the same architecture afterwards. So next, I'll try to talk about what we do in doing the model training. Actually, we apply the free text into the pre-trained model, the embed model, and do the fine-tuning for our application, which is the embed is a pre-trained model for the natural language processing, and we put our multilingual input, which is here, the questionnaire response into as the data set, and do the tokenization and do the model fine-tuning. And finally, we obtain 2 different models for occupation and for the industry. And this is the architecture. As I said before, we have a pre-trained multilingual but model fast, and we do the fine-tuning based on the census data and also the general household survey data. And we try to fine-tune the embed-based encoder layer at this one. And then we obtained our model and do the prediction after doing the softmax and try to get our best predicted class. Actually, we can obtain the top few trustable classes, but in our application we try to obtain the top 3 into our application. And here is our coding classification results. And we used it around 472,000 of the records for our model training, which involve the free text and also the industry and occupation code. Namely, here is the table for a number of classes, and accuracy is around 85 to 90%, and the average score achieved at 90% for the model. And after we do the model fine-tuning, it is the application part. We then try to put the multilingual natural language input into our fine-tuned model and get two different results. The first one is the predicted occupation and industry code, and also the corresponding probability of the predicted result. And this probability is used for our risk-based mechanism later. And here's the proof of concept to application. We try to put our fine-tuned model into our process and the workflow. And to improve the accuracy, we try to use a risk-based mechanism with human in the loop in our application. Namely, firstly, we have the predicted results just said before. We try to extract the low probability samples for manual coding. Secondly, there are some classes with the previous result in the historical result as low accuracy. Then we would try to pull them out and put into the manual coding. And thirdly, after we put this manual coding results into do the manual coding, we will do the quality check of the manual coding, and finally we will sample some trusted result, which means with high probability of the samples and with high accuracy in previous samples, we would extract these results. We sample some of them for manual coding too. And this is the risk-based mechanism, and we would do the manual coding as the human in the loop for the application on this framework. Okay, after putting the risk-based mechanism and the human in the loop mechanism into our true application of the framework, the accuracy of the occupation code and industry code would be increased into 95 to 97% afterwards. And it also reduced the manual coding work from previous census and also the general housing survey as before. And this application is work in our 2026 population census now. So to talk about extendability of our coding auto-coding framework, firstly, we try to describe some of our departmental data collection platform first. Firstly, we this as Hong Kong Census and Statistics Department, we developed our data collection platform to support the fieldwork management and also the data collection process, which is generic for a different survey and also support the configurable data fields, which means we can add or remove some of the data fields in different surveys, and also support a multimodal data collection method. And what is the extendability of our model is like we try to use the API approach and also as a plugin on this auto coding framework into our data collection platform, and it supports support us to extend it to different data fields on model fine-tuning easily, and just like we can extend the auto coding into the general housing household survey, and also it can adopt our model retraining and support some modern architecture. For example, if we obtained a new data from our population census later, then we can do the model retraining on our embed or even we can apply it into a more modern or a transformer-based model for our training application. It is configurable and also is extendable. And lastly, the sampling rules and also the risk-based mechanism is configurable with those parameters in our systems. And therefore, in our full pictures of the application and the framework, it is extendable and also configurable for our application. And for a conclusion, this is the roadmap we have done before, and we do the full manual coding in the very first in previous census and also previous surveys. Then we want to do it in a more smart way. Then we develop our classification model with the latest technologies, those LLM models. And after developing our models, then we applied them into the system and and developed our risk-based mechanism with him in the loop, and which is extendable and also configurable into our system, and put these application into actual process. And we used this AI assisted system in our daily work in the 2026 population census. And for the future, because of the extendability of our model, then we can improve the performance, like retrain the model, use the new data, put them into the model for the training, and improve the performance afterwards. And this our future work. And that's it for my present now, and see if you have any questions on the presentation.
Thank you very much, Michael. That was a very fast, but also very rich presentation. We will leave the questions for later, but
Sure.
I'd like to mention that I was quite impressed by the fact that this is a multilingual type of approach that you have taken, as well as the capability to scale up. As you said, you can extend it to other types of surveys and other coding applications. So that's quite impressive. I'm sure people may have a lot of questions, but let's leave them to the end.
Sure.
So thank you again, Michael. And let's now move on to the next presentation, which will be by Mr. Kyungmin Im. He's the Deputy Director at the Data and Statistics Research Institute of the Ministry of Data and Statistics in the Republic of Korea. So, Kyungmin, you have the floor.
Hello, can you hear me?
Yes. We can see your screen.
Good afternoon, everyone. My name is Kyungmin Lim. Today, I'm honored to share Korea's journey in automating statistical classification using AI. I'll walk you through the past, present, and the future of our classification coding. Statistical classification is fundamental to our work, allowing us to understand detailed status information such as by region or industry. Most of this coding relies on analyzing unstructured text data. For example, the Korea Standard Industrial Classification consists of 1,205 detailed categories. Even for our seasoned expert, mastering the entire system and matching it to text data is a daunting task. This challenge becomes even more acute during large-scale operations like a census, where we rely on temporary workers with less experience. Historically, statistical agencies have used two main approaches. First is the case library method, where experts build a rule-based system using keyword combinations. While highly accurate, it suffers from low coverage and requires immense time and effort to maintain. Second is index-driven method, which uses algorithms like TF-IDF to score matches based on word frequency. This solves the coverage issue, but often results in low accuracy. Ultimately, both methods requires humans to manually verify every single result, consuming vast amount of labor and time. In 2020, Korea began researching AI-driven automation. A critical strategic decision we faced was whether to use commercial services like ChatGPT or develop an in-house system using open source. Due to concerns over data privacy and the risk of hallucinations, we choose to develop our own system. By 2022, we successfully built a system that utilizes a pre-trained language model to learn from fast data and provide classification results. Technically, we utilize the Robota model based on Google Spot and applied the high-TC algorithm to reflect the hierarchical nature of statistical classifications. After training on approximately 170 million text records from 5 major previous surveys, we achieved a classification prediction accuracy of about 85%. Between 2023 and 2024, we compared this AI approach with our traditional methods. The result showed that AI not only provided higher accuracy, but also statistically improved processing speed through GPU servers. So, does AI mean full automation without human intervention? Not exactly. What has changed is that we now have a prediction accuracy score that tells humans exactly where to focus their review. While the average accuracy is 85%, most units exceed 95%. Lower accuracy typically occurs in categories with small training data sets or other categories. By focusing human expertise on these high priority areas, we have significantly streamlined an editing process and reduced workloads. Furthermore, the system improves after every survey cycle by retraining on new results without the need to manually update complex rule sets. Based on this result, Korea has decided to fully transition to AI-based classification starting in 2025. It is already being applied to the population and housing census, and this year it will expand to economic census and the household income and expenditure survey. We are also preparing to apply AI to more professional fields, such as the cause of death statistics and maintaining administrative data for the business register. Looking ahead, we are focusing on the potential of small-scale generative LLMs. We plan to compare our current bot-based models with LLMs and analyze the effects of fine-tuning and lag. To conclude, I'd like to briefly answer a few questions we received in advance. First, regarding offline or low bandwidth situation use. Our system is designed to integrate with survey systems via API. Additionally, we have built a website that provides a search function for statistical classification. While the website currently limited to internal staff, we are considering external services once we address GPU resource challenges. Second, regarding other agencies, yes, the model can be adapted to different classifications by building dedicated training datasets. Finally, regarding data size, we recommended at least 400 records per classification unit for reliable result. Because we prioritize reliability, we currently do not use LLM-based data augmentation for units with insufficient data. Thank you for your attention.
Thank you very much, Kyung-min. That was a very interesting presentation, and I particularly liked the fact that you used the fact that the structures are hierarchical to help with the classification, as well as our next presenter. We have Mr. Sarsen Janabekov. He's the Deputy Director at the Information and Computing Center of the Bureau of National Statistics of Kazakhstan. So Sarsen, you may have the floor.
So, hello everyone. Can you see my screen?
It's coming up. Yes, I can see now.
So my name is Sarsen Janabekov. I'm from Bureau of National Statistics of Kazakhstan. I'm responsible for digital transformation, introducing new big data sources, and implementing AI tools. Let me start from a brief context of this project. So since 2022, National Statistical System of Kazakhstan has been undergoing major digital transformation. And one of the direction is to introduce big data sources into official statistics. The main goal of this transformation is to increase the quality of statistical information, the accuracy and frequency of statistical information, and at the same time to reduce the reporting burden from our respondents. And one of the promising big data sources is scanner data, which contains information on retail transactions and registered by cash register machines in retail retailers. So this data can be used in CPI estimation, retail trade volume estimation, or household consumption estimations. So today I'd like to share our experience in the use of AI-based scanner data classification for CPI estimation. So as you know, CPI is one of the most important statistical indicators, and traditionally in Kazakhstan it is collected monthly with the help of over 300 employees. They collect 120,000 quotes monthly from 12,000 basic objects and manually. While scanner data could help us to increase coverage and accuracy of information because it contains around 37 million quotes from 124,000 retail outlets around our country, and it can be automated, and it can help us automate and scale our estimation of CPI. The data sets we received from Ministry of Finance, for example, in 2024, it contained 6.8 billion annual records. The data set contains variables such as product name, transaction quantities, and unit price. So everything that we could use for CPI estimation. However, with this big data, big challenges also arise. For example, when it comes to scanner data, the product names are not standardized and entered with retail objects by themselves. That's why it can vary significantly between different retailers. For example, one single product can have over 100 variations of names. In this case, I showed the product name. In English, it would be in potato. In our case, it's kartoffel. It has so many variations that the traditional rule-based classification tools couldn't handle and couldn't classify it properly, especially when it has some abbreviations or some specifications that are not known for classification tools. That's why we needed to develop automated classification tool based on AI so that we could scale this information and use it to CPI estimations. Last year, we initiated the project to develop AI-based system to classify scanner data. The end goal was to eventually introduce scanner data into official statistics. We used the fiscal data from Ministry of Finance and enriched it with our statistical business register. So the key effect would be to increase the accuracy of CPI estimations and to reduce the cost of surveys related to CPI. The whole project took around 12 months. We started from data cleaning, and because the data sets from scanner data from retailers contain significant amount of noise and inconsistent formatting and typos. That's why, first of all, we had to clean this data and normalize data set. Then we started to train our model. We explored different scenarios, different models, and decided to use a combined approach. First, to train, to label 100,000 product names, we used open AI model GPT, and it helped us to classify the training dataset, and then we generated embeddings based on our localized models, BGM3, and then we scaled it into our whole dataset. So we used to train our whole dataset, our local infrastructure, and then categorized it and introduced it into CPI calculations. We also spent a couple of months to test this approach, to validate results. For the project, we assembled the project team, consisted of project manager, data scientists, data engineers, IT engineers, and most importantly, domain experts who helped us to construct and integrate our results into official statistics. As a result of this work, we classified with high accuracy 290 product categories. Just for your information, our CPI contains 535 categories, so which means that more than half of these product names we categorized successfully. In some cases, it also failed. For example, when it comes to ambiguous names or corrupted some typos, it couldn't handle this kind of product names. But mostly, when the scanner data contained clear product name or brand name, it could classify it with high accuracy. And one of the most important part for us was to integrate these results into official statistics to make it production ready. So we spent also a lot of time to make it production ready and to integrate into official statistics. Out of these 290 product names that I showed you previously, we analyzed it for regional coverage and regional representativeness, and identified 75 product names. And now this 75 product names with high regional coverage are part of official statistics. And from 2026, it is part of CPI estimations. So we hope to increase this coverage. But one of the most important challenge that we should handle is to increase not only data labeling or our models, but also to increase the fiscalization across regions, because not every region has good representatives in terms of fiscalization, and scanner data only covers the major cities for some products. That's why we are working with Ministry of Finance, Ministry of Trade to increase this coverage, and we hope that in a couple of years we will be able to increase the coverage of scanner data and introduce more product names into CPI estimations. But we see now that the AI tools can be used for classification, especially when it comes to big data sources. Although this project and this kind of projects require substantial investments in terms of infrastructure, a project team, and developing new methodology. But we believe that the results show that it is worthwhile, because in the end it will increase the accuracy, user satisfaction, and decrease the cost of sample surveys that we collect traditionally. So this is it from my side. Thank you.
Very much, Sarsen. This was a very interesting presentation, a different type of coding classification, this time not for survey, but rather for scanner data. And also very interesting to hear some of the challenges in the coverage, the geographical coverage of the scanner data, and as well as the accuracy for certain product names. So certainly you chose a very challenging way to apply AI, but it's very nice to hear that it's possible, and you have already some results that are incorporated into the CPI. So fantastic. Now, thank you very much again, Sarsen. Let's move to the last presentation, and it's by Luke Rowntree. He's a senior data scientist at the Central Data Science and AI Group in the Office of National Statistics of the United Kingdom. Luke, you have the floor.
Thank you very much. So I'm going to be speaking about ClassVI, which is an open source package developed by the UK Office for National Statistics. So it's for survey coding in general. So it's a generalized package that we're currently using to underpin or as the backend for several internal tools around occupational coding, industrial coding, and also being trialed for some CPI coding. There's several other applications we're considering it for as well, are currently testing things out for. So we're keen to get more people interested in using it. It's free and open source, so please try it if you're interested. So the context of the problem we're trying to solve: survey responses, which are usually free text, need to be mapped to distinct classification codes. These often follow a hierarchical structure, so at the most granular level, there can be up to, say, 1,000 codes. There's substantial human effort is needed to assign these classifications, and also the human clerical coders need to have rigorous knowledge of the official taxonomy associated with these classification systems. So ideally, we would automate or assist with this as much as possible, but traditional natural language processing or machine learning techniques, they often struggle when there's this many categories, and also typically they need enormous amounts of data to train on. So usually they don't deal very well when there's semantic similarities or differences between the training data and the new data. For example, if you're doing occupational coding, if the training data only has references to lecturers in the university, then a new survey response containing the job professor might be misclassified. So our answer to this was to develop the ClassVI package. So ClassVI uses LLM encoder models to project text into a semantic vector space, where text which is similar to each other will be encoded as vectors which are nearby each other in the semantic vector space. So this addresses the professor-lecturer type issues, so it can be able to extend beyond its training data essentially. So this flexibility, which is essentially a very extreme version of fuzzy matching, so it's flexibility in semantic relationships. So that drastically reduces the amount of training data you would actually need to get good performance. So the approach we use in ClassVI to our classification system is to take a good quality historical data, which has been labeled already. We embed that as vectors. We save that along with the original text and any metadata we want to be able to refer to later. So we save that to a vector store object, which is then persisted in storage as well. So then once we have that done, the vector store object has some methods attached to it. So an incoming query, such as a new survey response, can be searched against it to find the nearest historical records. So because of this, we're not doing true classification. Instead, we're more doing nearest match retrieval kind of setup. But then in post-processing, you can apply rules such as, if the distance between your new response and some historical record is below a certain threshold, then you can auto-code it, or if it's near a certain record and then the next nearest is further away, you might want to apply a rule for that. So you can tag on your final classification step on top of this document retrieval type approach we're using. So the classify approach, whenever we're searching, so a new query is first embedded as a vector, and then we calculate the distance of that embedded vector from every other vector already in our vector store, which is our historical data. So then we return to the user the top n historical examples along with their distances and any other metadata they've asked to be saved and so on. So how do we count distance whenever we're talking about vectors? So there's many different ways of doing this, and each of these has different implications for what you mean by semantic similarity. So there's two common ones, which are the L2 distance and cosine similarity. So L2 is good if the emphasis of a text is meaningful, and cosine similarity is good if actually it's the intention behind the text that's more meaningful. So currently in Classify, we restrict using cosine similarity because we find it's in general for the survey responses we've been looking at, it's the most meaningful, but we do aim to offer a choice in future. So there's two key advantages to the overall approach we take. There's no actual training step required. So the user specifies the vectorizer model they want to use, or builds their own and attaches it to it. And there's no training required, so it kind of works out of the box. And then also the classification decisions can be explainable. So if you use the closest document retrieval and then a coding decision based on that, you're able to say that for a new survey response X, I'm encoding it with the code 1234 because it was very similar to another historical record Y, which a human coder confidently assigned as 1234. So this means you can explain results or pass auditing and so on. So whenever you use Classify, what comes with it? So we provide vectorizer models. So these are ways of transforming text into numerical representation. So we have ones which can interface with LLM encoder models available from Hugging Face. We have able to interface with the Google Cloud Platform vectorizers. We can interact with a locally or externally running Olama server. And we also provide a base object if you want to create your own. So some users have so far created older ones with this, such as TF-IDF or Ngram-based vectorizers, as well as but potentially you could attach it to an AWS one or use some custom one you've built yourself. So we also have a vector store object. The vector store object takes in your historical labeled examples. So it needs to have a text description field and an ID field, where the ID field is your coding scheme. So for example, if the code is 1, it could be the text could be the quick brown fox jumped over the log. So these are encoded with the vectorizer to form the database. And then once that's all done, there's methods attached to it. So you can directly embed some text to get the vector back, or you can search some text or a batch of text, in which case you will get back the nearest n historical examples for some n you specify. Or you can do reverse search, where you instead pass in a classification code and you get the examples from the from your historical examples. So for example, if we were doing occupational coding, we might have something that looks like this. So you've got your codes here. Typically we'd have several. We would recommend a pure minimum of 10, but ideally as many as you have available of good quality ones, and some text descriptions for each of them. So these are several records, all corresponding to the code 101 and so on. And then it's any other metadata column you want to include. For example, here I've got which survey these come from. So whenever you've created your vector store, you just use the .search method and pass in your query, and you'll get back the closest matches with the rankings of which is closest and the scores associated and the metadata you've requested. So a new feature we've added recently are hooks. So these are used for pre and post-processing tasks. So you can apply them to any of the vector store's inputs or outputs, and they can be used for things like data cleaning, data sanitization, linking external data sets. You can aggregate your results at the end. You can either define your own functions to do these, which is quite straightforward to do, but also Classify will be providing, in the next version which is coming out soon, it'll be providing some default ones for common tasks. One of these that we're particularly proud of is a hook for retrieval augmented generation for interacting with a generative AI model. So we've got this set up so that it's able to take in the output of a vector store search. So it's the nearest examples retrieved from a vector store search, and then ask it to do another task based on those. So in the case that we want to do classification, then we can provide it with the this information, and we can ask it, can you decide based on the retrieved document texts and the original query, which of these is the most appropriate? So we're actually going from it beyond it being the most semantically similar to actually generative AI actually thinking it through and making that decision. In this case, it's been the same. Another option is to do re-ranking. So if you don't want to make it quite as automated as that, you can actually ask it to take the semantic rankings and see, do you want to change them with your extra information it has. Then also you can do more arbitrary things, so it's very customizable. So in this case, I've actually asked it to do keyword identification. So it's just pulled out the single word from the document's text here that it thinks is most useful in making the decision around how it should be classed. So Classify comes batteries included. So if you want to get started really quickly for testing things, everything is available. This 15-line code snippet is everything you need to vectorize text, create your vector store from historical data, and then expose it as a REST API service. So we come with vector store, come with a choice of vectorizers, and come with some server functionality. So we standardized on Fast API, so it can either create a new Fast API server, or it can be attached to an existing one, depending on how you prefer it to be. If you have some existing implementation you want to attach it to, so you can pass in a request like this, and you'll get back a JSON response like this. So this is modeled after the previous slide, which was done via the Python interface. So why should you use or try to use Classify to see if it's suitable for your use case? It's free and open source. It's easily accessible and installable via pip on almost any system that can run Python. We've got a detailed documentation website that will also be released within the next month. And it's very flexible, so it comes batteries included and facilitates customization. We provide a lot of options for things you can use, but also we provide base classes and make sure it's as easy to extend as possible. So you don't need to wait on us to make new features, although we will be keen to make any people think are going to be useful. It's very fast. So we use efficient polars, which is essentially pandas, but built with Rust, and NumPy for the internal processing. The outputs are actual pandas data frames, so there's no actual extra dependencies for the user. And then building it is fairly quick, but also it's a one-off cost. Whenever you're actually searching against it for a single search term, it's microseconds. And if you're searching for very large batches, the most you've experienced is still in the region of seconds. If you're doing fancy post-processing, including the retrieval augmented generation, this does take longer. So that is one consideration. Feedback. If you give us feedback, we directly use our users' experiences, and that shapes the direction of the development. So if you give us feedback that you want a feature or you had an issue with this, these are things we will actively look to address. So thank you very much for listening. I'll leave this slide at the end where I've started to answer some questions that were submitted in advance. Thank you very much.
Look, I really like this solution by your team at the UK because it's open source and free. So it's a very good approach to make the solution that you're building also available to others. So excellent. And also the fact that you are even improving it and adding more features. So this is excellent. So yes, there were a few questions that were sent during the registration. And as well, I see that there are some questions in the chat. So now it's time for us to have a discussion. And by the way, from previous Stats Cafés, I think the feedback we got from many of you is that we would like to have more time for interacting with the speakers. So now it's the time, and we can have questions on the chat. We can have questions if you like to turn on your microphone as well. Let me allow you to also unmute yourselves. So, and also we can have questions also by the speakers as well. If any of the speakers would like to ask each other questions, you're also welcome to do so. Perhaps to get the ball rolling, if you like to have a question, you can raise your hand. And I'd like to first ask one of the questions I saw in the chat about the infrastructure that is needed to run some of these classification tools. I would like to know. I think Luke already responded about this case, but I'd like to know then from the other speakers what kind of infrastructure is needed and how did you actually deal with that part? Yes, Kyungmin, go ahead. Any of the speakers would like to come in and talk about the IT infrastructure needed to run?
So Korea wants to address the question, and we're going to use the translation, the simultaneous translation.
네, 한국은 A107대의 GPU 서버를 구축해서 활용하고 있습니다.
107대.
A100 서버, A100이 제품명이에요. 7대.
So in terms of the servers, we use A100 and we use 7 of those A100 servers.
네, 그리고 한국은 AI 기술이 조사 시스템과 통합돼서 조사가 이루어지는 현장에서 AI 결과를 제공하는 것을 목표로 했습니다.
And one of the key features of our classification system, AI-based classification system, is that it is integrated into our survey system. So these classification coding is done on site while the survey is conducted.
저희가 보유하고 있는 A100 7대의 장비로 버트 기반의 현 알고리즘의 운영에는 무리가 없습니다. 그런데 LLM 활용에 있어서는 제약이 있는 상황입니다.
And our current server capacity, which is 7 A100 servers, can afford or can run on the BERT model, but it is limited to run the LLM-based models.
그래서 장기적으로 GPU 자원을 더 확보하기 위한 노력에 총력을 기울이고 있는 상황입니다.
And for that reason, our focus for our future expansion and development is to secure more GPU capacities for the servers.
Thank you very much. Maybe other speakers would like to also add. Michael Sarsin.
In Hong Kong, our application in BERT model is separately into two parts. The first part is the model training, and the second part is the application. About the model training, we used the GPU around 40 GPUs for the model training, but for the application, we only used a CPU, i7 CPU, the 13 generation with 32 gigabytes of the RAM for the model application, and the time we used it is around 80 minutes for 10,000 records. It means it runs around 125 records every minute in the actual application. And because we put the application into our process work in our workflow, it is not real time for the response. It is in the coding and editing process, and therefore we can do the scheduled job for the classification, and it just used the CPU and use the RAM in a low capacity of the application.
Thank you, Michael. So if I understand right, in Korea, because you're doing kind of a real-time classification, you need quite a lot of GPUs running the classification. But the strategy I hear from Hong Kong, China, is that to use a lot of GPUs to do the training, and then afterwards run the classification in a kind of a low-cost server. But that takes longer to classify, but it's not a time-sensitive issue because you can run it over a longer period, right? I think if I can summarize the strategies.
Yes.
So how about you, Sarsen? I know you have more records. I heard more than 1 billion records. So how do you handle that in terms of infrastructure?
Yes, for data labeling, as I mentioned, we don't have our on-premise solution. For data labeling, we use OpenAPI APIs, GPT-5. So we use our traditional servers, like normal servers, CPU-based servers. And then when it comes to generating embeddings and classifying the whole data set, we use our local infrastructure, which is based on small GPUs, like 4090 GPUs. But now we are planning to move towards our governmental supercomputer, which contains H100 GPUs, and this is our next step. And this would allow us to increase the speed and make it even data labeling on premise. So now we have combined solution with the open API solutions and our localized classification infrastructure based on our CPU and small GPU capacity.
Thank you, Sarsen. Let's move to the next questions. I see that Rohit has the hand raised. Would you like to ask your question, Rohit?
Thank you, Dan. Question is to all the panelists. A few points which I thought I'll just raise with all of you and understand your views on that. First is LLM versus BERT. Which approach you feel would be most suitable in this case? Second is mixed approach versus embedding only approach. So some of them were mixed approaches and some of them were only embedding approaches. Third is open weighted model versus API. And how can we make all these configurable, all our solutions configurable? So these are the few points. And lastly, rather than giving one solution, one code to the user, will it not be a better approach to give 3 options to the user out of, say, hundreds, and then let the human take over from there? Thank you.
Thank you, Rohit. Many questions. Anyone would like to start?
And Dan, I've written in the chat box also, in case.
You added to the chat. Thank you.
Yes.
Any of the speakers would like to answer? Luke, would you like to say something, Luke?
Yeah, I'm happy to answer. So yeah, we
Yes.
agree with giving the user a choice for a start. That is mostly because we're making an open source package that we want to be as general as possible. So in terms of LLM versus BERT, so we default to using the encoder, the LLM encoder models, which are the easy, cheap ones. So essentially, that's just converting from text to vectors. So that's so the embedding only approach is our default. This is a lot cheaper and generally gives you a very good starting point to see if if you have enough information available to make a sensible classification decision. After you've got to that point, you might want to look at doing something like retrieval augmented generation on top of that, but you still want to have narrowed down your list of candidates so that you're not using an enormous amount of tokens to do your generative processing. So you would still want to use something like the embedding approach as well. At least we have found that. In terms of how can you make it more configurable, so the way we approached the package was to try and give the user as much of a choice as possible in what tools they use within it. It's more of a framework than anything else.
Thank you, Luke. Anyone else would like to answer these questions from Rohit?
Okay, for our approach, we used it, but because we have to own our own model for our application, even in low collections or in security way. And secondly, because we have a large amount of the data, around 472,000 of the data for the model training, and also we will the model will be future used for further fine tuning, and also if we have some coding changes, we will have designed the forget gate, and therefore for the gradient descent and also the gradient ascent approach to fine tune the model for future use, and also for the extendability, we used the embedding approach instead of the mixed approach set. And also we avoid using the API approach for the scalability and owned our own models in our devices for the application, and therefore we try to use this way to build our own model instead.
Thank you, Michael.
Comment for this question?
Sarsen, yes, please.
Yes, these are the questions that we were asking ourselves actually in the beginning of this project, and we were exploring different scenarios. And because of our infrastructure restrictions, we didn't have and we still don't have like much GPU capacity, and we decided to use mixed approach and use partly APIs, and then to use and to have our local model. And when it comes to performance, we saw that this like sufficiently enough, it showed sufficiently enough good performance. But as a next step, we are planning to explore fully on-premise solutions and use open weighted models.
Thank you.
So
yes.
from Korea side, in terms of the BERT versus LLM, when the data set already has sufficient training data for selecting the correct answers, then a BERT model is more efficient in terms of cost efficiency aspect. However, when the correct answer is not really clear, or it's or the data set is insufficient with correct answer cases, then LLM's inference function is needed. And in that case, the GPU capacity will be a consideration because of the requirement of large GPUs for the inference by the LLM. In terms of open source versus API, our biggest consideration is the information protection. And for that reason, Korea started from the BERT-based model, and to to ensure the data protection, we are now moving into small-scale LLM using enough GPUs to run those small-scale LLM.
Thanks everyone for the answers. Perhaps I'll move to the next question. I see the hand of Maindra. Would you like to unmute yourself and ask your question?
Okay, thank you, Diane. It is continuing my first question via chat. Thank you for all panelists for answering my first question. So, my name is Maindra from Statistics Indonesia, BPS. In June and July, we plan to have economic census. In the questionnaire, we plan to ask the respondent about the classification of industrial, So we plan to use AI classification here, but as our big consideration is whether the concurrent user of the people that use the classification AI, because in economic census next June we have 250,000 enumerators. So we want to know your experience here from the panelists, how many users that use the AI application in concurrent time. So this is my question. So thank you.
Thank you, Maindra.
Yeah.
Yes, I think that the case of Korea was actually, if I understood correctly, does real-time processing as well, which I think is what you're aiming at with your question. So perhaps we can hear from Kyung Min if you had that experience of doing real-time and how many users could be supported.
25만 명이 동시에 시스템에 입력을 하는 상황은 아닙니다.
So our situation is slightly different from Indonesia. We do not have 250,000 users concurrently or simultaneously accessing our servers at the same time.
조사 기간 동안 트래픽이 분산되어 있기 때문이죠.
That is because during or across the survey period, the access to servers are distributed somewhat.
한국의 예를 들자면 25만 명을 대상으로 하는 조사에서는 수천 명의 조사원이 동시 서비스, 실시간 서비스를 받는데 에러가 없었습니다.
So from a concrete example of Korea, where the survey population was about 250,000, that required a couple of thousand enumerators, and our system didn't have any problem accommodating those couple of thousand surveyors.
총조사가 센서스 같이 400만 건의 자료를 전체적으로 돌리는 데는 저희 시스템상 2-3시간이 소요됩니다.
However, when we process data for censuses amounting to 4 million records, our system took 2 to 3 hours to process large-scale datasets.
리얼타임 서비스는 이 바운더리 안에서 몇 명의 조사원이 얼마만의 조사 기간에 작업을 하는지에 따라 계산할 수 있을 것으로 보입니다.
So considering these benchmarks, that stems from Korea's cases. Maybe you can calculate how big of the system capacity you need, considering the duration of surveys, the target population of that survey, and also the enumerators that you're going to need for that survey.
Thank you very much. Seems like the scale of things in Indonesia is much bigger because of the large population. But I think that the good message here is that it is possible if you have the right infrastructure to support that many enumerators using concurrently the system. I think also that using these in real time is perhaps the frontier application for this, so that it's probably the next step for many NSOs that are already doing this. I see another hand, Wei Chen Lei. Would you like to ask your question?
Hi, thanks for organizing these presentations, and congratulations to all the participants and presenters. My name is Wei Chen Lei, and I'm actually from IO, and I see a lot of interesting points in the presentations, and IO is actually the custodian of ESCO classifications. So what you're doing is very relevant to us, I think. And also we do understand that the classification problems and auto coding is it's a tremendous challenge. I mean, we can see that all you have done great work. Just one information before I ask questions. So IO, probably you already know that IO is currently on the ESCO revision process. So the new ESCO revision should be available around 2028. So we are currently in the revision process. So I mean, if you have any questions or suggestions, that you could contact me, or we may reach out to you bilaterally. So my question is for Luke. That I know that understand all the other way of all the other presenters that has mentioned about infrastructures, and I know that it quite resource intense for training. But in these solutions that Luke provided, that I had a brief look, and I think, if I understand correctly, you're only using the APIs to call the either LLM models, commercial LLM models, or the open source models, right? So if I'm not using the RAG features, then it's all based on the APIs.
Sort of. If you're using the Google Cloud Platform vectorizer, then you need to be able to interface with Google Cloud Platform. And similarly, if you're using other API providers of vectorization, you need to be able to interface with them. But the Hugging Face one and the Ollama one, you can run that locally on your machine. So if you download the weights, then you can run that locally. Or if you generate the weights yourself, or from some other get them from somewhere else, you can host and run that locally. And because the encoder models are very small, the ones we've been using are typically under gigabyte. It's quite easy to use. So we have several users running them directly on laptops, and I've tested running them on a Raspberry Pi.
That's amazing. That is this also like if you run this in a local LLMs Ollamas, that is this also? Yep, does it can also handle the large scales data set?
So your hardware will affect your performance, but in general, the vectorization process is not very intensive compared to generative AI. If you use bigger models, you will get better performance in that, but they do get slower. But we've got fairly reasonable performance with the Almany LM and the Nomic Embed Text, which are two of the smaller but good quality embedding models. They're both free and available on Hugging Face.
Thank you very much.
Thank you. Thanks, Luke. I saw that there was a question in the chat from my colleague Richard about the ability to handle different languages. Richard, would you like to ask your question? I'm not sure if you can hear me.
Oh, hello. Can you hear me?
Yes. Yes,
Yeah.
please go ahead, Richard.
Okay, thanks. Yeah, no, this was a question specifically to Luke. Just very interested in the extent to which other NSOs could potentially adopt the Classif AI tool, it's particularly those using non-English languages and those with wondering if there's particular challenges, for example, languages that don't use the Roman alphabet, if that provides extra challenge. Thanks.
So this is something we haven't actually tested yet, but we don't think it's a software or knowledge thing that's stopping us from testing it. We just don't have good data to test it on. So we'd be very keen to try it, or if you would like to try it, we'd be very keen to hear how you get on. It should just be swapping out the vectorizer should be the only thing that's required. If you're doing retrieval augmented generation, which we will make available by the end of the month, then there may be other considerations that are limitations based on the model you're using for that. I think so. Currently, the feature we're going to be adding is locked in on the Google Cloud Platform's Gemini. So in a later release, we may try and make it more flexible to be able to use any. But from my knowledge so far, the Gemini models are quite good at handling multiple languages. I can't speak for non-Roman alphabets, that may be a different concern. I think that shouldn't be an issue for the vectorizers, though, if you're using a multilingual embedding model.
Thank you, Luke. Maybe I should call also on Michael, because from his presentation, he mentioned that the model was trained with a multilingual data set. And I wonder, why did you choose to do that? And what was your experience with that?
Because in our census or in our general household survey, we have different response in English, in traditional Chinese, and also in simplified Chinese. And the response would be a mixture of these three different types of languages, and therefore we use the multilingual model to tackle this problem.
So I assume also because you had Chinese, traditional, and simplified.
And English.
In English. This means that you also had different characters, right? So different.
Yeah, and the response might be a mixture of these three kinds of the language or written language because of the culture of Hong Kong census and also the surveys. And therefore, in the natural language process, we need to use the multilingual approach.
Thank you. Thanks, Michael. Perhaps we should take our last question of the day. My colleague Christoph sent a question in the chat. Perhaps, if you like, Christoph, would you like to ask your question?
Yes, sure.
You can unmute yourself, yes.
Yeah. Hi, everybody. Thank you for this very interesting Stat Café, by the way, and for the presentation. I just had one question. We know that accuracy can hide some issues with the small categories, and you always have imbalance in the categories when you do classification. So I know that Michael mentioned the fact that for these small categories, there is a special treatment applied to that, and also another classifier for that. But I would like to know the share of this additional work on this small category compared to the bulk of all the other work that is automatically classified. Just to know what is the cost of the additional small category in terms of the total classification. I know it's a little bit technical, but this small category or this niche kind of jobs. And by the way, I tested the the tool by your colleague from India, and I tried to put my job, which is a niche, and it didn't end out very well. So it seems that this small category of work, in this case, are not often very well classified and need manual treatment. So I want to know a little bit more from our speakers. But once again, thank you for all of that.
Thank you, Christoph. Anyone would like to answer to this?
Okay. For Hong Kong cases, we do the manual sampling in risk-based approach, which means if the class with a small amount of data, then after the predicted model is applied, then the probability results might be in low accuracy, and therefore we would do the manual coding. This is the risk-based approach. And secondly, if the accuracy before in the historical model training is in a low accuracy, then we will pull them into the manual coding. And therefore, for the those in imbalanced data in small amounts of the data, small amount of the classification results, then we'll pull we'll have a higher probability to pull them into the manual coding sets, and therefore we will sample them into manual coding. And finally, about the method we use to treat these small amounts of the data, because actually those imbalanced data and those class in small amount of data is in a low proportion of the whole data set, and therefore the manual effort is comparatively lower than the major classes we can see. And to pull them into the manual coding would not affect the whole effort in general, and therefore we use this risk-based approach to increase the accuracy with the human in the loop to increase the accuracy with no harm to the whole manual coding effort, we'll say.
짧게 좀 부탁드릴게요.
Thank you, Michael.
So
Yes, Kyungmin.
Korea also takes similar approach with Hong Kong. So we also take the human in the loop approach and pre-designate a certain categories or certain areas with a small classification or small size classification as the area to be handled manually. So that is in our system, it is called high priority areas for manual reverse. And that's how we handle these small categories.
Thank you. Okay. So with that, I also thank also for the answers that many of you provided also in the chat. I'd like to close with a few more slides, but before that, let me thank the presenters, Michael, Kyungmin, Sarsen, and Luke, for your presentations and for this discussion as well. I have a few announcements I would like to make before we close, which are very important. My colleague will share the screen. So we will have our next Stats Café on the 30th of March, and it's going to be a very exciting topic. It's titled Lessons Learned from AI Pilot Initiatives, what worked, what didn't work, and why. So we'll be exploring some of the successes and challenges of getting into AI. So it'll be a bit less technical than today, but again, it will be a very interesting discussion as well. So we look forward to having you all here again on the 30th of March. And also in the next slide, I would like to share that we are here in ESCAP, part of this DASH team of AI for official statistics, which is an expert group across Asia-Pacific that is working on how to use AI for statistics. We have now started collecting case studies of your experiences in the country of using AI. And we would like to hear from you about your experiences as well. And we just launched a survey that you can submit your use cases through the online form. And these use cases will be then compiled into a repository that will be available very soon, as well as will help us identify cases where we can also present during Stats Cafés like this to share experiences to more countries. So if you have experiences in AI in your country, even if they're still in the pilot phase, feel free to submit them. There's a QR code, and I think yes, Richard just posted now also in the chat. So please save this link as well, so you can submit your use cases of using AI. And by the way, all the national statistics offices have been also informed of that through the official channels, but sometimes it may not have come to you. But if you're interested, you can talk to your colleagues in the NSO, and probably some of them have already received our email about that. And finally, if you have not yet been part of the LinkedIn group, please join the Asia-Pacific Collaborative on Official Statistics. It goes beyond AI, but it's a group that we share our information about what's happening in Asia-Pacific in terms of official statistics. So if you want to be up to date on the events and the publications and even other discussions, please join this LinkedIn group. Also, I think someone will add to the chat this link as well, so you can join. So we're reaching the end of our time. So I'd like to thank all the participants for being here and participating in this Stats Café, and special thanks to the presenters for all the insights shared today. As we said before, the presentations and the recording of today will be available on the website that you can review later. So thanks everyone, and have a nice day.